Assalamu alaikum students. Now this is video number 5 for the preparation of end of term 2 final exams in statistics. As you know, I have already shared with you video number 1, video number 2, video number 3, and video number 4 on different topics. Now this video number 5 is the last topic, which is cumulative frequency curve, along with some advantages and disadvantages of statistical measures, whether it is measure of central tendency, and I mean averages, mean, median, mod. What is their advantage? What is their disadvantages? And another important thing, the second aspect of statistical measures, which is the measure of variability, which is to find the spread. So you know that there are different type of spreads we have found in statistics: range, interquartile range, and standard deviation. Then finally, we have drawn some diagrams, guys: stem and leaf diagram, histogram, cumulative frequency curve, and box and whisker plot. So all these things which we have studied, I want to highlight their advantages and disadvantages. They are very important, topics for the end of term to final exam preparation. First one is median. Why median is no. First one is mod. Okay, let's go with the mod. Advantage is it is useful when the most popular category is needed. For example, clothes or shoe sizes. As I said in the class, that mod is normally used for qualitative data. So you can write here advantage in the exam. It is more suitable for qualitative data sets rather than the quantitative data sets. And he has also said that the value which is most popular category in the qualitative data, that gives you a quick information about the average in terms of mod when you are trying to find it. So whenever you are dealing with qualitative data, and you want to quickly give the average, you have to see which one is the most popular category contained in the data set. However, it has many disadvantages. You know that it is not useful for a very small data set or when there are more than two mods. If in the data set we have like three values are repeating with the same frequency, and they are there are three mods of that data sets, then how come we can say that all the three mods can represent the average? So more than two mods, that is not suitable. Another thing is there may be a mod. If I write a data set in which none of the value is repeated more than one time, so we cannot find the mod in that data set. So this is also the disadvantage. It may not be the representative. For example, it could be the lowest value. Um, if I give you a big data set and the lowest values are repeating most frequently, how come I can say that the lowest value can be the mod? Because mod is the average is always the central value. So it cannot be the extreme value. The model class depends upon the grouping of the data. Yes, when you group the data, different people have different way of grouping, the data sets. So the variation in the groups cannot tell you that exactly where is the model class, so where the model value is lying. So that's also the disadvantage for the mod. It is not useful for further analysis. Yani if you want to go for example, when you calculated mean, you can find standard deviation. Mod is like it's not very helpful if we compare it with median and mean. In medians, we draw a cumulative frequency curve. In medians, we go for box and whisker. You know that, guys. So those averages have some advantages, but mod is just suitable. A quick information if you want to get from a qualitative data which value is appearing most frequently, then mod is useful. Otherwise, there is no use for mod. Now come to the median and mean. They are very close to each other. First of all, I want to highlight the importance of median. Median says it is not affected by the extreme values. As you remember, median is the 50% value when we arrange the value from lowest to the highest. So the 50% value will be the median. So I can say that median is not affected by the extreme values. That's a very useful thing for median. Another important aspect is it can also be found as soon as the middle value is known, such as the distribution of times of runner in a race. And if you are trying to calculate the median and the runners are running, suppose 10 runners are running, and once the fifth runner runs, and you calculated the fifth and sixth runner runs, and you calculated the median, then you stop it over there. You don't need to wait for the 10th runner. You understand my point? You are actually concerned about the 50th percent value. So median can be calculated quickly or than the mean, because mean you have to rely on all the values. I will talk about it. But the two important, the advantages for median is that median is not affected by the extreme values. Number one, and number two is for the median, you need not to wait for looking into all the values of the data. Once you see the 50% value, then you ignore the next upcoming values because you have already calculated your median. What is the disadvantage? The disadvantage is it does not use the whole data set. As I said that median is not representing the whole data set. It is just concentrating on the middle 50%. So whole data set, it is not depending upon. And another important disadvantage, likewise, mod, for further analysis, it is not very useful. And for further analysis, it gives you the median 50%. Now, extreme values are not discussed over here, so we cannot talk about its furthermore impact on the data set. However, we can use it for comparison. We can use it for comparison, as we will use it in box and whisker plot or in cumulative frequency curve. But for further analysis, he says that like in mean, we found the standard deviation based on mean, but in medians, it's an isolated value. We cannot further take information from that. But in my understanding, the best disadvantage is it does not use the whole data set. Okay. Um, mean. Mean is it is calculated by all the data values. Yani mean cannot be calculated if you don't have the full information. So that's a plus point for the mean, that it takes on board every value which is given in the data set, right? And it is calculated using a mathematical formula, and so calculators can be programmed to find it. Yes, everyone knows mean is sigma x over n if it is not a frequency table. But if there is a frequency table for it, then we have formula sigma fx over sigma f. So there is a mathematical formula for the mean. You can also write it as advantage of that. It is extremely useful for further analysis, as I said, because all the values are used. That's why mean is very helpful for further analysis. The mean has one disadvantage. When there are some extreme values, then mean is not a suitable idea, because if we consider those outliers or extreme values, they will definitely damage my average. So try to avoid mean when there are any extreme values contained in the data set. Now we come to the measure of variability. Range is very easy thing, which is equals to maximum value in the data minus minimum value in the data. Number one, it is very easy to calculate, and it completely tells you how much the data is spread. However, it is range is badly affected by the extreme values. Suppose if you have very big values and very small values, and you, because you want to consider them to find the range, so I can say that range is affected due to the extreme values. Now next thing is interquartile range. I know interquartile range is basically a range of middle 50%. So it's middle 50% range, yani upper quartile minus lower quartile. Um, how it is useful, it is not unduly influenced by extreme values. That's the plus point of interquartile range if we compare it with range. In range, it was extremely affected by the extreme values. However, interquartile range is the difference between the 25% and the 50%, 75% values, the middle 50% of the data. So that data set is not affected by the extreme values. Another important thing, it can be used to investigate extreme values. Yes, there is a formula in statistics, in advanced studies, you will study that if you want to identify which values are outliers or extreme values on the basis of the information of interquartile, you can easily find the outliers of the data. What are the disadvantages? It depends only on the particular values when the data are ranked. Same like median, it is, yani median was 50%, lower quartile is 25%, and upper quartile is 75%. So once you calculate lower quartile, upper quartile, you cannot, give any information about other values. So they are isolated values. They are not giving you any information about furthermore information contained in the data. Standard deviation is another way of measuring the variability. It is calculated using the data, so represents every item. Same thing, standard deviation is related to the mean, because if you calculate the mean, you can find the standard deviation on the basis of the provided mean. So in mean, we used all the data set values. Same thing in standard deviation, we used every value. There is a mathematical formula for it. That's also a plus point behind standard deviation. It is very useful for further analysis. As I said, if we want to find some more useful measures about the data or the comparison of the data, standard deviation is also a helpful tool. It is useful in comparing two data set values. Yes, guys, as I said, in box and whisker, or maybe in when we have any statistical diagram is given, or any statistical distribution is given, we can find standard deviation and we compare the two standard deviation. That also helps us to compare the two data sets. Then the disadvantage, as like mean, it is affected by the extreme values. For a single set of data, its value is difficult to interpret. Definitely, it's not easy. You can interpret the value of the standard deviation. It totally depends upon, first of all, mean, and then you see that how the values are spread around the mean. So no one can easily interpret it. You have to use the formula, and then from the formula you can find it. In interquartile range and range, you can easily see that where are the values lying. However, standard deviation is not very easy to calculate. We have to rely on a formula which gives us the information about the spread of the data. Now we come to the stem and leaf diagram, guys. Very important for the final exam and for the Cambridge exams. Actually, if you see the mostly in past papers, they give you diagrams for their disadvantages and disadvantages, but it doesn't contain more than 2 marks. So guys, you need to know what are their significances and what are the disadvantages of these diagram. Number one, stem and leaf diagram, it shows all the original data. As you saw that in mean, when we said that mean takes on board every data set value, and stem and leaf diagram, we have to represent yani all values as leaves, and with the related stems on the stem and leaf diagram. That's a plus point of stem and leaf diagram. Also, it shows the shape of the distribution, horizontal histogram, you know, or horizontal bar chart you can see along if the leaves are symmetrically distributed in their rows. The mod, median, and quartiles can be found easily from the diagram. Yes, guys, as you saw in the previous videos in stem and leaf diagram, I was finding medians and quartiles. I can also find mod. Um, uh, I like this one a lot, you know, stem and leaf diagram, which is a back-to-back stem and leaf diagram. Back-to-back stem leaf diagram is helpful for comparison of two data sets. Huh. The biggest problem in stem and leaf diagram, if the data set values are very big, any large amount of values are given to you, you cannot draw a box stem and leaf diagram. You have to rely on some other diagrams to further analysis of the data. Histogram, guys, you know that histogram, we have rectangular strips. It can be used when we have different widths. You remember, guys, the idea of frequency density. If you have group frequency table and every group has a different width, the histogram is an ideal diagram to represent the data set distribution. It shows whether the distribution is symmetrical or skew. Yes, guys, the symmetrical, histogram, or if it is tilted towards right or it is tilted towards the minimum values, we see that the distribution or the shape of the distribution can also be easily seen from the histogram. The mean and standard deviation can be estimated from the histogram. As you remember, that histogram is based on frequency and frequency density. From the frequency density, you can calculate frequency. If you have the frequency, then you can easily calculate mean and standard deviation of the data. Uh, what are the problems we face in histogram? The visual impact can be altered by choosing different groups. As you remember, guys, the model class was also affected if we choose different groups. So changing the groups will change the shape of the distribution. So that's why histogram is not an ideal thing when we use different groups. So two distribution cannot be shown yani, as the multiple bar charts, but bar chart is different from the histogram. In bar charts, the widths are same. In histogram, we can represent only one category, in histogram, but in the multiple categories or multiple rectangular strips cannot be drawn in the histogram. So two distributions are not, ideal for representation on this histogram diagram. Cumulative frequency curve, guys, you remember that, and inshallah in this video I'll explain it to you. The median and the quartiles or percentiles can be easily estimated from the graph. Cumulative frequency curve is very ideal to compare the two data sets, like we use box and whisker and cumulative frequency curve, and also back-to-back stem and leaf diagram. They are good to compare the two data sets. Okay, cumulative frequency curve, guys. If you choose different scales, same thing like in histogram. If you choose different groups, but in cumulative frequency curve, we don't use groups, we use scale, horizontal scale. If different people have different scales, then the shape of the cumulative frequency curve will be changed. So that's the problem in cumulative frequency curves. Boston Whisker, guys, very easy. It is based on 5 values only: minimum, maximum, lower quartile, upper quartile, and the median. Um, it is easy to see the symmetrical distribution or skewed distribution that is the median tilted towards the left or to the right, and you can easily calculate the outliers, as I mentioned it, guys, the significance of quartiles, that you can find the extreme values. There is a formula for that. So in box and whisker, I can say that which value is extreme or outlier for me. I can find easily range, I can find interquartile range. And if you want to compare the two data sets, again, box and whisker is an ideal diagram. In box and whisker, guys, the complete information is missing. It is just based on 5 values. That's why if a person wants to see the information, the information of all the data values, no, that is missing over there. You cannot see it, and it is not showing frequencies. That's all with the advantages and disadvantages, guys, of every statistical measure which we took in these two chapters. So now I have brought for you the two questions which I put in the revision pack. Please come to the page number 13. This is an exam style question. Enable measures the length of 200 caterpillars. Guys, in the final exam, when you see any cumulative frequency curve, you have to check that how many total values you have, 200. So I have to show those 200 values here vertically, 200 values here. They must be labeled here. And you need to check that every box is representing vertically how many units. And at the same time, guys, the lengths of the caterpillars, the scale is um, along the horizontal axis. So as you see the cumulative frequency curve, like an S-shaped curve, it is already drawn. I can find median, I can find lower and upper quartile, or also I can find the percentile. So now the first question is estimate. Why he used the word estimate? Because it's a graph. We cannot find exact answer for median and interquartile range. Guys, now try to note this point for median. I'm not going to use that formula n+1/2. No, I will just go to the 50% of the total value. So 50% I will use. Interquartile is 75% value minus the 25% value. This information I will actually extract from the graph. So how many total values we have? 200. Now I need a ruler, guys. So in the ruler, the half of 200 is 100. From the graph, it is very clear that each box is representing 4. So this is 84, then 88, then 92, then 96, and this is 100. Okay, so I'm gonna draw 100, 9, and then I go down here. This is my as you can see, this is my median. So this is 3.2 is my median. Also, I want to see where is my 50, the lower quartile. Guys, can you check? I found 50% of 200, which is 100. And from 100, I go down and I found the median. Now 40, 44, this is 48, and then next is 52. So I cannot go to 52, take the middle of that. So it gives me approximately so 2.1, 2.2, 2.3, 2.4, 2.5, 2.6 is my lower quartile. Now I want to find the upper quartile, 150, guys. So this is 156. This is 152. And then this is 148. So may I take this one, half of that? Approximately, it gives us 2, 3, 4, 5, 6, 7, so 3.7. So my median is 3.2 in centimeters. my interquartile range Q3 minus Q1, which is 3.7 minus 2.6, which is equals to 1.1 centimeters. Next question, estimate how many caterpillars have length between 2 and 3.5 centimeter. 2 and 3.5, guys. This is 2. This is 2. This is 3, 3.4, and this is 3.5. Okay, let's move further. 1, 2, 3, 4, 5. So this is 3.5. Can I go up? I need to know what is this. And I also need to know how much is this, right? Okay, guys, so I can check that the value which I found from here, it is 24. And from here, I found it as 134. So I need to find in between how many caterpillars are coming. 134 minus 24, which is 110 caterpillars. So 110 caterpillars we have. Now he said 6% of caterpillars were having length or more. Okay, we want to find that L. Can I find 6% of 200? When I find 6% of 200, that gives me 12. But this 12 is not from here, not from here. No, we have to find from the top. So from the top, 12 is where? This is, guys, 196. This is 192. And this is 188. So I have to go 12 units down. Go straight here. Strike the curve. And then you have to go down. Straight. Approximately, guys, it gives us 4.5. Okay, so this is the length gives you 4.5 centimeters on the scale, approximately. Right now, we have another question. Assalamu alaikum wa rahmatullahi wa barakatuh.